To understand the limitations of most enterprise AI platforms, look at how they treat tools as flat, isolated lists. An agent picks a single function, runs it, gets a result, and stops. It is a linear process, and at scale, it will inevitably crumble under pressure. When developers try to force this linear system to execute complex business outcomes, they end up writing monolithic scripts. They pack data fetching, formatting, statistical analysis, and API routing all into one massive file. These massive scripts duplicate logic across the organization. Because they are rigid, other agents cannot reuse their individual parts. And if a single third-party API updates its routing, the entire script fails. This flat list architecture restricts AI to basic single-turn tasks. It structurally prevents agents from managing true, scalable enterprise automation. HeartBeatAgents operates on a different logic. Tools are not flat lists. Instead, a skill can autonomously call another skill, which can call another. This chain can reach up to 5 levels deep. At every single tier, the active skill retains full access to enterprise databases, external APIs, and the agent's long-term memory. There is no drag-and-drop workflow designer. There are no manual pipeline builders or external orchestrators mapping these connections. The agent determines which skills to compose and in what order at runtime. Simple, single-purpose building blocks automatically combine to execute complex workflows. Orchestrating this depth requires strict management of permissions and state. That management is handled by a single mechanism, the execution context. This context dictionary is assembled at the start of a run. It maps everything the skill needs: organization ID, database sessions, memory store, and tool registry. The critical design rule is unbroken propagation, flowing downward into every level without structural changes. This handles security automatically. Authentication tokens are managed by the credential broker, never touching the underlying code. Because the context propagates intact, a subscale buried 3 levels deep maintains the exact same security protocols and operational power as the top-level trigger. Consider a real enterprise scenario. A user prompts an agent to generate a comprehensive weekly competitor report. The agent searches the organization's library and pulls existing, discrete primitives. It finds an HTML fetcher, a data parser, and a validation checker. The agent natively writes the code to connect these standalone parts. It chains the primitives together, adds trend analysis, and formats the final output into a single cohesive unit. Because orchestration relies on the agent's real-time reasoning rather than a human's pipeline design, simple, reliable parts generate emergent enterprise complexity. Composable systems carry a hidden risk. Tracking which skills rely on other skills usually requires human-edited configuration files, which inevitably drift from the actual code. HeartBeatAgents solves this by reading the actual Python abstract syntax tree. It scans the structural logic of the code itself, bypassing text strings and comments to isolate exact registry calls. This structural extraction identifies the functional code that executes at runtime, avoiding false positives common in string-based matching. This extraction ensures absolute portability. If a skill is exported and imported into a new organization, the platform re-extracts the dependencies from the source code instantly. By making the raw code the absolute source of truth, the platform eliminates human configuration drift and silent breakage. Resolving and loading deep dependency trees presents a severe performance challenge. Fetching dozens of skills sequentially would require dozens of slow database trips. The platform counters this latency with an O-of-1 architectural optimization called Recursive Batch Preloading. The algorithm executes only a single database query per horizontal depth level, regardless of how many skills exist on that tier. To protect the enterprise database, the system enforces hard safety guardrails, a maximum depth of 5 levels, and a load limit of 200 skills per run. If 2 skills mistakenly depend on each other, a visited set mechanism silently skips the redundant fetch, preventing infinite loops. This batching process ensures that no matter how complex the agent-generated capability tree becomes, dependency resolution executes instantly and without latency. Highly composed architectures possess an inherent vulnerability. A single failing subskill can cascade upward, destroying every workflow that depends on it. The platform's first line of defense is a series of circuit breakers. When a node detects consecutive failures, it automatically isolates the broken node. Instead of crashing the larger system, the isolated node returns a clear error message. This allows the rest of the chain to gracefully bypass the failure or pause execution. The platform then initiates an auto-repair loop. It routes the error traceback and original code to an LLM, generates a targeted fix, validates it via the syntax tree parser, and resets the breaker. By combining strict isolation with autonomous code repair, historically brittle pipelines become self-healing enterprise assets. Stepping back from a single workflow, this architecture dictates how an organization scales its AI capabilities over time. When one agent improves a core building block, like a CRM data fetcher, every other workflow in the company that relies on that specific block receives the upgrade instantly and for free. This mechanism transforms an organization's tool library from a flat list of scripts into a dense, interconnected capability graph. New agents no longer start from zero. They inherit and compound the historical knowledge and tools of the entire enterprise. Unbroken context propagation, AST Dependency Mapping, and instant batch preloading operate invisibly in the background to sustain this architecture. Consumer-grade AI platforms form on fragile, manual pipeline designers and flat toolsets to manage their agents. HeartBeatAgents maintains its own internal structure as the organization's library expands, requiring no manual reconfiguration to sustain its thousands of potential connections. This is the foundational operating system required to build, scale, and heal the autonomous enterprise.